Alright, let's take a look at some compound interest problems. And before we start a problem, let's remember the formulas that we want to use. Simple interest is equal to, interest is equal to principal times rate times time. And of course, the rate is always as a decimal. We never use the percentage. Principal would be how much we invested. Time would be in years, and I would be how much interest we earned off of that. That's simple interest. It's the easiest one to use, hence the name simple interest. Now, compound interest, we have A equals P times 1 plus R over N raised to the NT power. Now again, here A is the amount, or the value of the investment, or how much you owe on a loan. P is the principal, right? That's how much you borrowed or how much you invested. R is the interest rate, and that's always a decimal, always. Okay. N would be the number of compoundings. And we'll talk more about that in a little bit here. And T, of course, is time. Now, as far as the number of compoundings, we could have quarterly, in which case N would equal 4, because you would do that 4 times a year. Annually, N equals 1. I'm sure I didn't spell that right. But that would be, you'd be compounding it once per year. Monthly would be 12 times. Daily is 365. Okay. So those are two equations. And this is kind of an important one. And the other important one is A equals P times E raised to the RT. And this is for continuously compounded interest. Continuously compounded interest. Now, again, A is amount, P is the principal, R is the rate, and again, that's always as a decimal, and T is time. Okay. So let's take a look at a problem. Let's say that you have $783 to invest, and you can find an investment that will pay 7.7%, and that's compounded quarterly. And you're wondering, how much money would I have if I left it in there for 10 years? So we get the compound interest equation out, and you want to know the amount. And that equals the principal. That's the $783 that you've got to invest. We multiply that by 1 plus, now the interest rate as a decimal is 0.077. And that's over the number of compoundings. Now for quarterly, that's 4 times a year. And we raise that to the number of compoundings times the number of years. And when we put that into our trusty graphing calculator, we get plus 0.077 divided by 4 raised to the 40th power. You will have $1,678.77. cents. Okay. All right. Now, let's say that Zach was looking at his new snowmobile. And he was looking at a pretty nice snowmobile, and it had a price tag of $12,000. And he was looking at buying the snowmobile in 3 years. Now, he found an investment that paid off pretty high. It was kind of risky, but it paid off pretty high. It paid 12% interest compounded monthly. And he's wondering how much he needs to invest in order to have $12,000 after the 3 years to purchase his desired snowmobile. Well, Zach just gets out his compound interest equation and says 12,000 equals the principal, how much he's going to have to invest, and goes 1 plus the interest rate is a decimal, which is 0.12, divided by the number of compoundings, which is 12, and raised to the number of compoundings, which is 12 times the number of years, which is 3. Well, he gets his calculator out, and he calculates what 1 plus 0.12 divided by 12 raised to the 12 times 3 power is. And he gets 1.431. So to figure out how much he's got to invest, he takes 12,000 and divides it by 1.431 and gets $8,387.10. So he invests that much money, $8,387.10. In 3 years, he will have $12,000. Okay. Now, let's see. Let's say that, Lamira is wondering how long it will take to double her investment of $2,000 if she can get 8% interest compounded continuously. So, well, double that amount would be $4,000. So she sets up the continuously compounded equation. Says 4,000 equals 2,000 times E raised to the interest rate, which is 0.08 times T, because she wants to know how long it's going to take to double. So the first thing she does is she divides everything by 2,000 and gets 2 equals E raised to the 0.08 T. Well, at this point, now she says I'm going to take the natural log of each side. So the natural log of 2 is equal to 0.08 T. So T is equal to the natural log of 2, which is 0.693, and divides that by 0.08. And when she does that, she gets 8.663. So about 8 2/3 years in order to double her money at 8% compounded continuously. Okay. Oh, let's do one more of these. Let's say that you've got $12,000 to invest. And you can get a 15% interest rate, but you've got to leave it invested for 20 years. And this is compounded continuously. How much money would you have after the 20 years? Well, there we're looking for an amount, and that would be our 12,000 times E raised to the 0.15 times 20. Well, this we can stick right in our calculator. And we get $241,026.44. Alright. Well, I hope this helped. If you have more questions, let me know, and if we need to do another one of these, we most certainly can. Have a nice weekend.